So the first part is when you have like f of x is 3x minus 2 over x plus 5, and we have to solve for f of x higher than 1. Now, generally what happens is that when we look at a simple rational inequality, as a rule, what we do is we never cross multiply. So our first step is that this is 3x minus 2 over x plus 5 is going to be greater than 1. Now, when I bring 1 this side, what we get is 3x minus 2. So instead of cross multiplying here, because you lose out some of the important solutions, what we do is we bring 1 this side. So if I bring in 1 this side, what we get is negative 3x minus 2 over x plus 5, negative 1 greater than 0. Now what we do is next is simplify this expression. And so 3x minus 2, negative x negative 5 over x plus 5 greater than 0. And this simplify to 2x minus 7 over x plus 5 greater than 0. Now, whenever we have some inequality like this, our first temptation is to, okay, take and multiply this side to 0. Now, remember that it's a rational inequality, and your general solution of a rational inequality is decided by both numerator and denominator. So that's why what we do is on the number line, we're gonna put both the root of numerator, which is 7 over 2, around which the sign changes, and negative 5, at which there's a vertical asymptote. So as a rule, you remember that when you are drawing the sign diagram, you make sure to it that you draw, you take root of numerator and root of denominator, about which the sign changes. So now next step is to pick up the numbers in each interval. Now, for example, here I can pick up, let's say 4. If I take 4 here, you can see that 2 times 4 will be 8. 8 minus 7 is positive, over 4 plus 5, which is 9, which is also positive. So positive over positive is positive. In between minus 5 and 7 over 2, it is going to be, let's say if I pick up 0, you can clearly see that's negative. And anyway, if there's a root, you can see 7 by 2 is a root. The sign diagram has to have a different sign about the root. It is important because about the root, the graph switches from positive y value to negative y value and so on. Now, if I have, let's say this side, I can take, let's say here I have negative 6 or something. If I take, let's say negative 6, what we have is if I take negative 6, this is going to come as negative over negative, which is not going to be a positive value. So this is about the sign diagram. Now coming to the final answer. Now where is this inequality positive? So what we're going to see is that where it is coming positive. So you can see it is coming positive here and here. So our final answer that we're going to give for this equation or inequality is x greater than 7 over 2 or x less than negative 5. So that's our first general solution. Now, when you are doing, let's say, sketching the graph of this, obviously you got to have the equation of vertical asymptote, which is x equals to negative 5, equation of a horizontal asymptote, which is y equals to 3. Of course, like you need to have the solid knowledge about how to find out. So here, just a shortcut is if you see a linear equation over another linear equation, for example, of the form ax plus b over cx plus d format, the horizontal asymptote is y equals to a over c. Now what we get is, if you look at this equation is 3 over 1, that's how you got horizontal asymptote. Your y-intercept is at 0, negative 2 over 5, and your root is at 2/3. So root for this equation is nothing but 2/3. So it's 2/3, 0. Now when I want to sketch the final graph for this particular equation, now what I'm going to do is I'll just clean out this part, whatever, don't need it. So what I have got now is approximately everything that I need, apart from sign diagram for rational inequality. So I don't need sign diagram here. As long as they haven't specified it, you shouldn't do it. So now what we have is some of the relevant informations. Now we got to put it. So x equals to negative 5 is the vertical asymptote, which is here. We got y equals to 3 as the horizontal asymptote, which is here. And now we got the root as 0, negative 2/5. So 0, negative 2/5 is the root. Sorry, y-intercepts, which is 0, negative 2 over 5. x-intercept is 2/3, 0. So that clearly indicates here that the graph is something like this side. It is gonna have a horizontal asymptote here. It will be passing through this point. And of course, you're gonna have here as the final graph in this quadrant. So this is how the sketching of this graph looks like. So our next part is to write down this expression as a plus b over x plus 5 form. So this can be written as this format. So what we'll do is in this question, we can do with two different strategies. Let's say 3x minus 2 over x plus 5. I can do a little bit of rearrangement in this equation. So what I can do is I can just cancel this x by making it exactly equals to what I've got in denominator. So you can see that adjustment what I did is basically I added 5 and subtracted 5, keeping this x plus 5 in my mind. Now what I'm going to do is I'm just going to take one step, which is like this, to open the bracket and don't keep minus 5 now in the bracket. So it become minus 15 minus 2 over x plus 5. So if you see now, this becomes 3x plus 5 minus 17 over x plus 5. Now you isolate each term. What we get is 3 minus 17 over x plus 5, because this and this get cancelled, obviously after isolation, minus 17 over x plus 5. Now this is exactly with the adjustment skill. Now what we have is the second one is the division skill. Now with the division skill, when you look at, so what we do is 3x minus 2 over x plus 5. Whenever I'm dividing an expression numerator over denominator, it can be written as quotient plus remainder over divider. So if I take here 3, it will become 3x plus 15, negative 3, negative, so it's going to be negative 17. So what we get is the quotient is 3 and negative 17 over x plus 5. So you got exact same thing with two different techniques. So whichever technique you're comfortable with, you can definitely use that. Now what we have got is the D part is something which is a little important to read the problem. Now lots of times in just to finish the problem, what we do is we think that every time we have to map 1 upon x onto the function. Now, when you look at the question, clearly says f of x to 1 upon x. So what transformations will you do that reduces this graph onto this, not what we sometimes process as, okay, 1 upon x to this. So now what we got is, let's remember that there is no direct link that I can just specify, okay, this is how you got 1 upon x, or from some specific transformation directly, you can say that. But what we can do is we can use the previous part that we got, which is 3 minus 17 over x plus 5. So what I'm going to do is, so let's say here is my function, 1 upon x is here, and my function is here, which is nothing but 3x minus 2 over x plus 5. So even though I've been asked to do what transformations will map this to this, but what I'm going to do is first I'm going to do exact opposite, which is 1 upon x to this. So now when you look at this, my first step is to see, okay, vertical stretch factor by 17. I can do reflection in x-axis. So when I do vertical stretch by 17, I get 17 over x. When I reflect in y-axis, reflect in x-axis, I get negative 17 over x. What I do next is by translate by vector, translate 5 units to the left. So if I translate 5 units to the left, I get negative 17 over x plus 5, and then move. So this was 5 units to the left, 5 units to left. And now here it was, finally was 3 units up. So 3 units up if I do, so 3 units up is 3 units up will give me the final graph, that is this one. Now, when you're specifying the final answer, which is like going backwards, what you do is you take exact opposite sequence now. Instead of moving 3 units up now, you will move 3 units down. 3 units down. Instead of moving 5 units to the left now, you'll move 5 units to the right, because you're undoing the transformation exactly. 5 units to the right. Instead of, now you reflected in x-axis. Now if I reflect an object and reflect back, I get the original object. So what I do is I reflect this and I get 17 over x eventually. Now after that, here we did vertical stretch by 17. Now, in order to undo that, I'll do vertical stretch factor by 1 over 17. So that eventually gives me 1 over x as the final answer. This is something which is really interesting. And you got to remember the steps that we did here so that you don't make a mistake. Okay, the final answer is f inverse x and state its domain and range. Now, for example, if I have y equals to 3x minus 2 over x plus 5, to find out the inverse, obviously what we do is we interchange x with y, which is x equals to 3y minus 2 over y plus 5. Then you make y the subject of the formula, so which becomes xy plus 5x equals to 3y minus 2. So that becomes xy minus 3y equals to negative 2 minus 5x. And you can see final answer is negative 5x, negative 2 over x minus 3. So this is your final inverse function. As far as the domain of this is concerned, if you link up with the previous part of the graph, like what we had here, the domain of this was x belongs to real number, x should not be negative 5, and range was y belongs to real number, y should not be 3. Now, when you write in the final answer, it's exact, for the inverse function, it's exact flipping this particular domain and range. So when I look at the domain for this, now you can see that even from here, x belongs to real, x should not be 3, y belongs to real, y should not be negative 5. So this is how you kind of predict the domain and range for inverse function. So this as a question, this makes one of the IB style question, and I expect you to kind of keep it in your mind, the steps that I shown and the precaution that you should take.